Good morning everyone. Good morning Sir S.T.E.M. So for our performance task, I chose this equation right here, which as read is as as the square root of 1 plus sine x minus the square root of 1 plus tan x over 1 plus x to the power of 2 over x to the power of 3 as x approaches to 0. So to solve this first here, we must simplify. So the first step is to get rid of these two equations here. So step 1 is to simplify. So on this side of the equation here, we want it to be just straight. Okay? So let's grab this here. So with this, we can define this as x squared over 2 over x to the power of 3. So to simplify this further, is the same as saying, since there is 1 over here, there's also 1 over here, we can simplify this as 1/2 times x squared over x to the power of 3. So now, we can write the whole entire equation as this. Okay, so now the problem has turned to this. Notice how there's 1/2 plus x squared over x cubed. So we can simplify this expression right here by adding them together. So now we have x squared over 2x to the power of 3. So now we can write this whole equation once again as 1x over 2x to the power. Wait, sorry. Okay, so now when you divide two exponents together, it's the same as subtracting both of the exponents together. So for example, let's say we have 3 over here, x to the power of 3 and x to the power of 4. We can subtract these exponents and make it turn into x only. So with this, we can eliminate the x here and only leave x here. So we now simplified the whole expression to this. Now the next step is to make these radicals here disappear. And with that, I introduce you to conjugating. So conjugating is where you multiply the numerator to the numerator again and also the denominator. So let's see that on action. So what we took here is we took the numerator and multiplied it to both sides of this fraction. So let's not put this in equation for now. Let's focus on this side first. So the square root of 1 plus sine x times the square root of 1 plus sine x is equals to a whole number. So that means it's sine x. So over here, we multiply it by square root of 1 plus tan x. So we minus that. So it becomes tan x. So and below, we just put this here. So now we have x to the power of 3 times 1 times this entire expression here, which is the square root of 1 plus sine x minus the square root of 1 plus tan x. And don't forget to add the expression that we didn't do before. So it's now times 1 over 2x. So the next step here is to use the trigonometric functions in which tan x is also equals to cos x over sine, balik. Okay. Good. In which tan x is also equals to sine x over cosine x. And with that, we can rewrite the whole expression once again as this. So now we have come to this. So now you wonder, how can we even solve this? If the limit is is approaching to 0, so with this expression, we can simplify it by the rules of special limits as this. Sin x Okay, so if you ever come across a formula just like this, you can simplify it as this. It is by the rules of the equation that whatever values you put in here and whatever values you put in this formula or equation, that the equals will still be the same as this one. So, as simplifying this, we can now put cos x at the bottom. So the equation becomes this. Sin x minus sin x times the quantity of cosine x minus 1 over 3 times 1 times cosine x, and then within the quantity, since it's getting replaced, we put this inside. So cosine x as the quantity of 1 plus sine x minus the square root 1 plus tan x. So, do you recognize a pattern here? There's three special limits, like sine x over x and cosine x minus 1, or 1 minus cosine x over x. Alright, so the first step of simplifying or getting the special limit function of sine x over x is equals to 1, right? But notice here how there's only x to the power of 3. We can expound that x to the power of 3, which is equals to x to the power of 2 times x, would still remain the same. But for the sake of simplifying this entire equation here, we will have this. Okay, so don't mind the change of clothes. So now let's continue to this part over here. As you can see, there are two special limits within this equation, and this is sine x over x, and that's cosine x minus 1 over x to the power of 2. So now we divide these fractions by imaginary lines so that we can identify which to simplify and which to not. So let's start here. Sine x over x. By the three special limits based on your basic calculus that is presented within our class, we can say that this is equals to 1. And now, by this may not seem familiar, but if you search it in Google, it's called the Taylor special limit function. I will show a picture of it here. So now, let's go back to here. Cosine x minus 1 over x squared can be simplified as negative 1 over 2. And now mind you that these are times, since we splitted these fractions together. So let's not forget. Times or and now here. You may think that this is one of the three special limits or maybe the Taylor limits function, but it is not. We solve it by substitution the limit here. So I rewrite this entire equations over here, not accounting to the other ones, okay? But let's now solve it. So since we substitute the limit as x approaches to 0, the x here turns into 0. And also the x sine x here turns into 0. This also turns into 0. So now you can see how we simplify this. So the next step is inside this parenthesis here. So 1 plus sine 0, over here we have the unit circle. So as you may see, that the sine 0, based on the degrees, the coordinates that we have, this is cosine and this is sine. So the coordinates we have here is 0. So we may now plug this in as 1 plus 0. Now over here is the tangent. So the tangent is not very common, but we can view it as here. A tangent is equals to sine x over cosine x. And within this situation, x is x approaches to 0. So we may substitute this as sine 0 and cosine 0. But since we have this here, sine 0 is equals to 0 and cosine 0 is equals to 1. In this case, 0 over 1 is equals to 0. So 1 plus 0 is 1. And 1 plus 0 is also 1. So within these, we must finish this. So the square root of 1 is equals to 1. And the square root of 1 here is also 1. So now, if we add all these together, okay, so it will now be equals to 2. So you might wonder that why is it 1 plus 1, not 1 minus 1, unlike the top equation from before, which in this case, I will show a screenshot. Okay, so it is because we conjugated the formula. Conjugating, meaning when you conjugate a radical sign, it will become an opposite. So meaning that if negative was at the top here before, it now has become positive. So now we have cosine 0, which is equals to 1. 1 times 2. So now we have 1/2. So that's the final of this part of this equation here. So if we substitute 1 over 2x, meaning that 1 over 2x is just 0. So we can cancel this out as indeterminate. So this is an indeterminate part of the equation. So meaning that if we cancel this out, 1 times negative 1/2 and positive 1/2, it results to our very final answer, which is negative 1 over 4. And with that ends the explanation of this very, very long formula. So now, thank you. That's it. Thank you.